Hi guys, I hope that you're all doing well. In today's lesson, we'll do negative exponents in grade 10. So a positive exponent in the denominator is the same as a negative exponent in the numerator. For example, if you have 1 over 2 squared, if you want to make this 2 to the power 2 negative, you'll write this as 2 to the power negative 2. So do you see that you took this 2 to the numerator, so the sign of your exponent changed, okay? You took the base to the numerator to change the sign of your exponent. So if you have, let's say, 1 over a to the power n, if you want to make this n negative, you'll take your a to the numerator. So you'll write this as a to the power negative n, okay? So if you had, let's say, b to the power 3, or let's say to the power negative 3, and you had to make this negative exponent positive, you'll take your b to the denominator. Note that on the left-hand side here, where we have b to the power negative 3, there's always over 1 that we don't really write. So you want to take this b down there in your denominator so that your exponent can be positive. So this will be 1, because there's nothing in the numerator, right? Over b to the power 3. Let's try another example. Let's do a over b to the power negative 3. How do we solve this again? We'll say a, this is basically a to the power 1 and b to the power 1. So we'll say a to the power 1 times negative 3 over b to the power 1 times negative 3. This is this times that, this times that, okay? So it'll be, we start in the numerator, we have a. What is 1 times negative 3? It's negative 3. We go to the denominator, we have b, 1 times negative 3. What is 1 times negative 3? It's negative 3. So this will be b to the power negative 3. So how do we make our exponents positive? Your a will have to go to the denominator and your b will have to go to the numerator. We swap them. So this will be b goes to the numerator, so this will be b to the power positive 3. It was negative, now it's positive. Over, we take our a to the denominator, this will be a to the power 3. The sign of your exponent changes, okay, from negative to positive. So if you had to factor this out, this will be in a bracket b over a to the power 3. That way you know that you just FOIL, you'll say 1 times 3, which is 3, then 1 times 3, which is 3. So it'll take you back to that step. Now what if you had, let's say, 2 over 5 to the power negative 3? How does this work? You can list all these steps, or you can just realize that you can write this as 5 over 2 to the power positive 3. And if you don't understand this, please just rewind and check out this example. You'll see that it takes you to 5 over 2 to the power positive 3. You just swap your numerator and your denominator, and this sign will change. Now let's try a few examples. First example, let's do x to the power negative 3. Try to make this a positive exponent. How will you do so? You have to take your x to the denominator. So when your x goes to the denominator, you have nothing in the numerator. So this will be 1 over x to the power 3. Now let's try 5a to the power negative 2. How do we solve this? We have a to the power negative 2, okay? So we focus on this part. So we have to take our a to the denominator. This will be, remember in the previous example, you had x to the power negative 3 in your numerator, right? So when you take it to the denominator, you'll be left with 1. But in this case, there's a 5. So that means you'll have your 5 in your numerator over a to the power 2. It was a negative 2. Here it's positive. Okay? So please make sure that you check your factors. Let's try number 3. Let's do y over y to the power negative 2. How will you make this negative exponent positive. This will be, you take your y to the numerator and you're left with y to the power 2. This is basically y to the power 2 over 1, but you don't have to show the over 1. It'll just be y to the power 2. Number 4, we have 3x to the power negative 2 over y to the power negative 3. How do we make our exponents positive? So we can take this x to the power negative 2 to the denominator and take this y to the power negative 3 to your numerator. So what do you have in the numerator? You have a 3. So you write down that 3. Now we want to take this y to the power negative 3 to the numerator so that it changes from negative to positive. So this will be y to the power 3 or y cubed over, in our denominator we'll have this x to the power negative 2. So this will be x to the power 2. This video was brought to you by Spotify. Whether you love discovering new music, listening to podcasts, or creating the perfect playlist, Spotify has something for everyone. With the free version, you can enjoy millions of songs anytime, anywhere. Want the ultimate experience? Upgrade to Spotify Premium to enjoy ad-free listening, offline downloads, unlimited skips, and even better sound quality. No interruptions, just non-stop music and entertainment wherever you go. Download Spotify today and start listening to music your way. Remember, your exponent changes. Now let's try the last example under negative exponents. Number 6, let's try ab to the power negative 1, b to the power 5 over a squared b to the power negative 2, a to the power 7. How do we solve this? We can start by solving in the numerator first so that we simplify things for ourselves. Let's check, do we have the same basis in the numerator? We have a, it's just a. We have b and b. We have the same basis and they are multiplied. A b to the power negative 1, b to the power 5 is basically a times b to the power negative 1 times b to the power 5. Okay, so this will be b to the power negative 1 times b to the power 5. Okay, you can write this on the side, b to the power negative 1 times b to the power 5. You have the same basis that are multiplied. What do you do to the exponents? You add them. Remember your laws of exponents. Do not forget them. Please make sure that you constantly remind yourselves of how to solve the different laws. So you write down your base. You have negative 1 plus 5, which is, you write down your b. What is negative 1 plus 5? It's 4. Verify with the calculator. So that means in a numerator we just have a. So you write down our a. Then we simplified our b to the power negative 1 times b to the power 5, which is b to the power 4 over, we have a squared, let's move to the denominator. We have a squared b to the power negative 2, a to the power 7. Do we have the same basis or any common basis? We have a, b, a. We have a and a, we just have b there. So let's solve for a and a. This will be a. Remember, when you see a squared b to the power negative 2, a to the power 7, or just any variables, it's a squared times b to the power negative 2 times a to the power 7. Okay, so we have a and a, which is a squared times a to the power 7. This times that. You have the same bases that are multiplied. What do you do to the exponents? You add them. This will be, write down your base a, 2 plus 7, which is, you write down your a. What is 2 plus 7? 9. So that means in a numerator we solved for our a's. This will be a to the power 9, then b to the power negative 2. Okay. Now let's try to solve this. This is a fraction, and I told you guys in the previous videos that this is basically, you start with your numerator, ab to the power 4 divided by your denominator, which is a to the power 9, b to the power negative 2. Okay, you can just write this on the side or like in your exam paper so that it's a bit familiar for you. We have a b to the power 4 divided by a to the power 9, b to the power negative 2. Do we have any common basis? you have a and a, which is basically a divided by a to the power 9. Okay, you can cancel this so that it doesn't confuse us. So this is basically a to the power 1 divided by a to the power 9, right? You have the same bases that are divided. What do we do to their exponents? We subtract them. So this will be a to the power 1 minus 9, which is a to the minus 8. Okay, so we can write down our a to the power minus 8 there to show that we are done with a and a to the power 9. We're left with b to the power 4 and b to the power negative 2. You have b to the power 4 divided by b to the power negative 2. Okay, you have the same bases that are divided. What do we do to the exponents? We subtract them. So this will be b to the power 4 minus negative 2, which is b. What is 4 minus negative 2? It's 6. Again, verify with a calculator. So this will be a to the power negative 8 and b to the power 6. So we have to leave our answers, our final answer, as a variable or a number with a positive exponent, okay? So that means you have to fix this. So you can just write our 8 to the power minus 8, b to the power 6 over 1, okay? That way you know that you have to take this a to the power negative 8 to your denominator. In your numerator, you're left with b to the power 6. You don't have to do anything to it as you have a positive exponent. So let's write our b to the power 6 over this a to the power negative 8 goes to your denominator, so it will be a to the power 8. The final answer is b to the power 6 over a to the power 8. And that is how we deal with negative exponents in grade 10 exponents. Thank you guys for watching. Please like and subscribe. I'll do more examples.